We are on the Exam 3 review, number 1, part E and F. So these are going to be our absolute value equations. So remember that absolute value is distance. So when I see these absolute value symbols, I am thinking distance. So I'm going to read that as a distance greater than or equal to 2. Okay, so if I think about that on my number line, if I take a distance greater than 2, I think about 0 here in the middle. The numbers that are going to be farther away from 0 are going to have the bigger distances. Okay, so I'm thinking about 2 or bigger, and then -2 or smaller, right? Because I want to stay away from the middle, I want my bigger distances. So if I split that up, if I look at the one on the right first, that would be 2x minus 3 over 5 greater than or equal to 2. So that's going to give me this side of the number line. Then this one over here, I take 2x minus 3 over 5, and that'll be less than or equal to -2. So notice if you go to your original equation, the first time you write it, it looks identical. The second time, you flip the sign and you change that to a -2. Now my answer on my number line is not really going to look like this, right? These numbers are going to change. It's going to be the same basic shape. So I'm going to go back and I'm going to erase that. Okay, so it served its purpose. And I'm going to go ahead and solve these two equations. So I'm going to clear fractions by multiplying both sides by 5. I'm going to go ahead while I have the red pen and do all of that. Okay, so here I get 2x minus 3 greater than or equal to 10. So that would be 2x greater than or equal to 13. So divide by 2, it's a positive 2, so I don't do anything to my symbol. And I get x bigger than 13 halves. All right, so when I solve the other one, I get 2x minus 3 less than or equal to -10. 2x less than or equal to -7. Dividing by a positive number, so I don't do anything to my signs. All right, so here is my answer as an inequality. So if I go back to the number line, if I graph the first one, I want numbers that are 13 halves or bigger. So that would be 13 halves or bigger. The other one will be -7 halves or smaller. So notice the shape is the same as the one we started with, the shape of the number line. And when I put this in interval notation, my first interval goes from -infinity to -7 halves, including the endpoint. I put a union symbol in between. My second one goes from 13 halves to infinity. All right, so as long as I pick something within one of those two ranges, it will give me a true statement. Now if I look at F, F is a less than. So when I see this, actually I got to do one thing first. I do want to isolate the absolute value. So let's start by dividing by 2. And I'll get the absolute value of x minus 7 is less than 10. So I just want to do that first because when I'm thinking about my distance, I'm thinking about a distance less than 10. So on a number line, if you think about 0, 10, and -10, we're looking at numbers that have a shorter distance, so numbers that are closer to 0. So notice this interval is sandwiched between -10 and +10. So I'm going to do the same thing here. I'm going to sandwich between -10 and +10. I'm going to put my x minus 7 in the middle. When you do this, your symbols are always going to point to the left. All right, so then to solve this, I just have to add 7 to all three sides, and I get -3 less than x less than 17. So now I've got my answer. So if I put my final answer on the number line, it's going to have the same shape as the one I did in red. I can use a parenthesis or an open circle, whichever you like. So it's still going to be this piece sort of sandwiched in the middle. Oops, sorry, there goes my phone. I've got a telemarketer telling me about my extended warranty on my car. All right, so in interval notation, I want anything from -3 to 17. not including the endpoints.